Hello, this is Martin from ABES with another video clip about our geometry control software for segmental bridges. In this episode, I would like to talk a little bit about so-called global elements, whereby the most common usage for these global elements would be the exact installation or the support of this exact installation of guide pipes for extradosed or cable-stayed bridges. The underlying technical challenge here is such that these guide pipes need to be placed in very precise spots, and in order to fit with the pre-lengthened cables, and therefore the global the coordinates and the exact specification for these anchors and guide pipes for these cables needs to be kept, even when the segment itself deviates a little bit from the intended position. So when there are some casting errors and geoCon and our software would adjust for these casting errors, and the segment ends up in a slightly different spot because of these casting errors, the global element function allows you to put the guide pipe still in the intended spot, no matter what the segment does in terms of correction at the same time. So please consider this very simple example: one base segment here in the middle, 5 match cast segments on either side, 2 casting sequences, obviously, one going out here and the other one going out the other side. We have 3 control points at each joint, all very simple and basic. We also have global points prepared for this example. Let me show you. I'm switching off the control points and I'm switching on the global points. And this is what we can see. I have prepared a global point here named P01. And I have prepared a pipe 01 object here, which runs from here and into the segment as we can see here. Just for the record, these points are defined in global coordinates. They can be anywhere, but each of these elements, the point as well as the line, are associated with a specific segment. So in this case, we have this segment here, and this segment here is associated with this global point and this global line. Both the point and the global point and the line are defined in global coordinates, and no matter what the correction will be later on and what the adjustments will be in the casting yard, the setting out data for these points will be prepared in a way to ensure that these points will end up in their required global coordinates as specified for the global elements. Global elements can be defined within the geoDes as well as the geoCon environment. Obviously, we're looking at geoDes here, and the definition of global elements is done within the bridge objects. So let's have a look at the bridge object input dialog. In this dialog, we have several tabs here on top, and the global items tab is the place where we can define global points and global lines. Now, each global element is associated to a segment. So each global element, the point here, has a name and an association to a group and the segment within the group. And each global line also gets a name and an association to a group and the segment within the group. Getting the group and the segment names is a little bit cumbersome to type, and to facilitate this input, we have a list of available groups and segments here to the right, from which we can copy and paste to this table over here. Now, I said that the geometry input is done in global coordinates. That's mostly true, and these are global coordinates here. However, there are circumstances where this information, the anchorage points for cable stays, for example, is more readily available in a bridge-specific coordinate system, whereby the x-axis would run along the length of the bridge and y would run sideways. And if the bridge is not aligned to a global coordinate system, that creates difficulties. And in order to help these difficulties, we can, if we want, define a reference system up here, whereby x, y, and z define the origin of our reference system for the global point input, and the three angles alpha, beta, and gamma define the direction angles for x, y, and z. That's a choice we can use to have a local system that helps us input the global points. One more point I'd like to make is that these coordinates here defining the position of this global point, or these coordinates here, point 1 and point 2, in this case they are given in global coordinates, and they don't necessarily have to lie on the surface or even within the segment they're associated with. If we go back to our drawing here, we can see that the global point is located somewhat above this segment with which it is associated. And the same goes to say for the line. It starts above and it goes to somewhere within. And it even goes beyond the joint of that segment. And that's a situation that is possible in the context of guide pipes for cable stays or cables for extradosed bridges. Let's switch gears now and take the same example into geoCon. Here we are within geoCon. The green color indicates that this base segment has already been cast, and we're about to set out the two adjacent segments, one of which is the segment that has the association with our two global elements, the line and the point. Before we do that, I'd like to point to the Edit drop-down menu here, where we can view and edit the available global points and global lines. So we can add to the existing list here in geoCon, same as we did in geoDes, and we can even set up our local coordinate system pretty much same as we could in geoDes for this purpose. So as we can see, we're about to set out this segment here, and when we click on next, we get the setting out dialog. And in this setting out dialog, we are getting the setting out data not only for the match cast segment and the conjugate segment, but the program realizes that with our new segment, our match cast segment, there are two global elements associated, and it also gives us the setting out data for the point and the line associated with this segment. Let's accept the data and let's check the casting yard report here. And if we look at the setting out data for the casting yard, we can see that we get setting out data for the match cast segment, our 6 control points, the conjugate segment, again, our 6 control points. And we also get setting out data for the global point and the 2 points of the global line. There is one more detail I would like to point out here. With the global lines here, the setting out can be sometimes difficult, because not always can the surveyor view the starting point and the end point of that pipe element that's going to be cast in here, leading into the anchor. And a common way of assisting with the survey is to have steel bars that go in the pipe and then stick out from the pipe on both ends or on one end. And the end points of the steel bars can then be seen by the surveyor, and that is then used for setting out these guide pipes. This can be simulated within geoCon. If we go to the casting yard view, to our virtual casting yard, we have certain elements that we can manage within our virtual casting yards. And the one here at the bottom is called guide pipes. And I have already prepared one such guide pipe. I double click on that. And that's a very simple element. That's basically the rod I was talking about. The rod gets a name. I call it G-pipe. It gets a length that sticks out on the one side, and it gets another length it sticks out on the other side. So this rod is defined as sticking out 1 meter on the side of point 1 and half a meter on the side of point 2 of our guide pipe. If we go back to our setting out dialog, again, we've just seen that a little while ago. Here is the setting out data for our global point, and here is the setting out data for our global lines. And here in the last cell, it says no guide pipe. If we have a guide pipe available in our virtual casting yard, as we do, we can now click on this, and the drop-down menu will offer us the guide pipes that we have defined. We only have one, so if we choose that, the setting out data will change accordingly, accounting for the 2 lengths the rod sticks out on both sides. So we're getting new setting out data here for the end points of the rod, 1 meter on one side, half a meter on the other. With these tools, we can set out not only our segments in the match cast situations, we can also assist in the installation of the guide pipes for our cable stays that come in to this segment. I hope that was helpful. Goodbye.